2017 question, free response question number 4. This is a no calculator question, and this was probably the most famous question from 2017. A lot of tweets went out about it, a lot of memes were created about potatoes, but it really isn't that bad of a problem. Persevere. Just push through it and you can actually do the problem. Number 4. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees, so we have an initial condition at time t equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at t minutes can be modeled by the function h that satisfies the differential equation dh dt as given, where h of t is measured in degrees Celsius and h of 0, initial condition, is 91. So make sure you read that carefully. H is the solution to the differential equation. So dH dt is the temperature rate. H is the actual temperature. Letter A, write an equation for the tangent line or for the line tangent, so that's going to be easy. We know that as soon as we see the expression tangent line, we're going to write on our paper y minus y1 is equal to m times x minus x1. And we want the tangent line at t equal to 0, and we already know from our reading that at t equal to 0, the temperature is 91 degrees, so we know our t or our x value is 0, and our h or our y value in the equation of the line is going to be 91. So all we need is the slope, which is easily calculated because we have the slope generator up here as dH dt. So part A is a pretty easy question. So let's come down here and take a look at my work and compare yours to mine. So you can see that I recorded my initial condition or my point, 0.91. The slope generator, dH dt, at 0 only demands the temperature at that time, if you go back and look at the equation. So I substituted 91, subtract 27, and divide by 4. Now, honestly, you did not have to divide by 4. You could just substitute this as your slope instead of the negative 16, so be careful in your arithmetic. Don't lose points for that. And then I substituted the temperature value or the y value, the t. It's okay if you used x instead of t. That's not a real major sticking point. And then I'm going to remember we always get y by itself, so I added the 91 to both sides. And then they wanted me to use my tangent line to predict the temperature at 3, was it hours or minutes? I don't remember what it was right now. I'll look in a second. So I substitute 3 into my equation, and I want to keep reminding over and over and over and over, this is a perfectly acceptable, full credit final answer. You do not have to take a risk at doing the arithmetic and possibly making a mistake. So I just wanted to see what the time was. Minutes. Okay, so at 3 minutes. So that's letter A. Not bad at all. Letter B. They're being very direct. They're telling us, I'm wondering what's under this thing right here. I don't remember what I wrote. Oh, come back up here for just a second. I don't know what we're going to be. Well, pretty sure we're going to be solving a differential equation, but if it's helpful, you can distribute the negative 1/4, edit, undo. You can distribute the negative 1/4 into the parentheses at some point, if it's helpful, to rewrite the differential equation this way. And in part B, actually, this might be a really good place to do that, because in part B, we're finding the second derivative. Now, when we do that second derivative, remember, we're going to have to do it implicitly, and we're going to have to use the chain rule. So we will leave behind a dH dt every time we take the derivative of an h. And as I said just a minute ago, this format of the differential equation might be easier for you to find the derivative of, because now when I look at the first term, I know the derivative of negative 1/4 h is just negative 1/4 dh dt, and the derivative of that constant is simply going to be 0. And then they want us to use that second derivative to determine whether the tangent line approximation is an over or an underestimate. So let's remember and think about that. If the second derivative is positive, we have a curve that is concave up, meaning the tangent line is below and the approximation is too small. If the second derivative is negative, we have a curve that's concave down, the tangent line is above, and the approximations are too large. So that's why we're doing the second derivative. Looking at my work below, I find the second derivative, and as I stated above, I get negative 1/4 dh dt. There's my implicit differentiation, my chain rule. I'm substituting negative 16, which was the dh dt that I got in part A. So remember, let's slide this back up. Back up here, we had the negative 16 dh dt from here, because that's what the equation is demanding or calling us to substitute. And regardless of whether you actually show that as a 4 or whether you leave the answer like this, we know that that value is greater than 0, meaning the curve is concave up, meaning the tangent line is below, and the approximation is too small, or an underestimate. So look at my response. Since the second derivative is greater than 0 at t equal to 3, h of t is concave up, tangent line is below, and the approximation is an underestimate. Part B. Not bad. Part C. In Part C, they finally ask us to do what we've been expecting the whole time, except they give us a new function. They give us a function whose name is g in this case. And then they give us the differential equation, or the derivative, the slope generator for g, as given right here. G of t is measured in Celsius, and the initial condition is still 0.91. Our job is to find an expression for g of t. So now we are doing what we thought we were going to do the whole time: separate, integrate, solve, solve. You can do it, but you need to go slowly and be careful of your algebra and your arithmetic. So let's walk through that. So in Part C, I start with the differential equation, and you're going to get a point for doing a good separation. So I'm going to divide in this step right here, divide both sides by g minus 27 to the 2/3 power. I'm leaving the negative on the right-hand side. You don't have to, but it'll make your work a little bit easier. Then I can do a U-substitution here. I could let u equal to g minus 27, but when I take the derivative, there's nothing to compensate for, so it's not even a hard anti-differentiation. I moved the g term, the g minus 27, to the numerator and made the power negative, so that's just an algebra step. Did nothing on the right-hand side. Then, the anti-differentiation, I increase the power by 1, and I divide by the new power. Easy anti-differentiation on the left side. I anti-differentiate in terms of t. On the right-hand side, I get negative t, and don't forget plus c. The initial condition was 0.91, so there's the 0. There's the 91 being substituted. You can leave it as an ugly number if you're getting afraid of the arithmetic. I probably would at least try to get it to here. The cube root of 64 is 4, and 4 times 3 is 12. Now remember, one of the things that people struggle with is, where does that 12? It goes back where we stopped, which was right here. Okay? So this is where the 12 goes. So if you follow my work, I copy the whole equation again, just exactly like it was, except for now I'm substituting the 12 in place of C. So in this case, I solve for C first, then I'm going to solve for G. To solve for G, I divide both sides by 3. Now you could have just made one big fraction divided by 3, negative t plus 12 over 3. You didn't have to do each individual term. That's up to you. The next step is to cube both sides to get rid of the 1/3 power. Lastly, I'm going to add 27 to both sides, and that is my equation for G. And then they told me to use my equation to predict the temperature at 3. So I'm substituting 3 in place of T. And notice, I am not simplifying my answer. I'm leaving it just like that for full credit. Let's take a look at the scoring rubric. Letter A, you get 1 point for getting the correct slope of negative 16, regardless of what format you left it in. You get 1 point for writing the equation of the tangent line, and you get 1 point for using that tangent line to make the approximation, whether you simplified it or not, and your tangent line equation does not have to be necessarily in that format to get the credit. In part B, there's only 1 point, so either you understand the whole idea behind the concavity and you can determine which way the curve is concave and tangent line above or below, or you don't. It's all or nothing. Letter C, carefully look at your work. 1 point for the separation of variables. That's just getting the G's on the one side and the non-G's on the other. 1 point for both antiderivatives correct. 1 point for plus C and using the initial condition of 0.91. 1 point for the equation involving G and T, meaning that you got G by itself. And then 1 point for your approximation of G of 3. So you can get a maximum of 2 points if you forgot the plus C. If you forgot plus C, you can only get 2 points. That would be for the separation of variables and for the antiderivatives. If you don't separate the variables, you earn nothing, which I know that you all separated your variables. Over here where they have the 54 degrees, you can leave your answer, I call it unclean, for full credit. There are no points allotted in this particular free response for units, so if you did not put degrees Celsius wherever they had degrees Celsius, you are not losing your answer point.